Let's talk about a couple different ways we can represent intervals of numbers. Some of them we're already familiar with. So I know you've already seen a number line. I know you have seen inequalities before, and of course we've used words before. So let's talk about those first, and then we will get to the interval notation and the set builder notation. So if you look at a number line, you can see all the shading is on this side of 2. So we say that x, because we're talking about all these numbers, are greater than 2. See how the circle's on the 2 and it's open? That means strictly greater than, and we don't need the equal sign underneath it. And like I just said, we could use the words, the number is greater than 2. When we look at the next one, we see the shaded part is on this side of 2. Those numbers are all to the left of 2, they're lower than 2. So we use the inequality sign that points that direction. Since that dot is filled in, we get to use the equal sign underneath it, and we would say all the numbers that are less than or equal to 2. Looking at the third example, we see the entire number line is shaded except for one place. We see on the 2, there's that open circle. So it means that 2 is not included in all the numbers we're talking about. So you can just say everything except x equals 2. You can use that little not equals sign. And we could say all real numbers except for 2, just like I just said. And the last one, we have 2 separate ones. This one right here, the shading is in between those 2 numbers. So that's where the x goes when we write our inequality right here. We write the low number, which is -1. Here it is. We write the high number, which is 1. It's right there. We put the x in between them because the shaded part is in between those 2 numbers, making sure we leave space right there for the inequality signs. Since this is an open circle, and since that's an open circle, we know that we will not have equal signs underneath them, and the signs will always point to the left as long as you order your numbers from low to high, which we did. So that one's taken care of. Since there's 2, we write or, and we'll do the same thing with the other inequality. The low number's 3, there it is. The high number's 4, it's right there. The x is in between because it's shaded in between those 2 numbers. And this time, both of the circles are filled in, so we will have the equal sign, and like I said before, your arrows, the direction of the sign, will always point to the left as long as you write your numbers from low to high. To say those out loud, we would say numbers between -1 or 1, but not including them. I would add that right there. Or the numbers from 3 to 4. So just to recap, if you see no equal sign, you're going to use an open circle. And if you do see an equal sign underneath, you will use a closed circle. You might want to jot that down on your paper if you think you'll forget. Next, let's look at the way they filled out the interval notation column. So this has to do, again, with the low and the high number, kind of like when we were writing the compound inequalities down here. So let's look at the number line. We have 2 as the lowest number that's involved with this, so there it is. And then that arrow keeps going forever and ever and ever in that direction towards positive infinity. And normally when we write positive numbers, we don't put the plus sign in front of them, so we just put infinity. We have a comma in between them, and then we decide whether or not to use brackets or parentheses. We use parentheses when you're not including the endpoints. That would be when you have open circles, or if you either have positive infinity or negative infinity. In this case, we have an open circle by the 2, so there's a parenthesis, a curly one, and we have a positive infinity, so it will also be a curvy one. Let's look at the next one. This time the arrow is pointing all the way down here forever and ever and ever. That direction is negative infinity. So there's the negative infinity. The highest number the shading goes up to is 2. So there's the highest number. Put a comma in between them, and now we decide on brackets, the straight ones, or parentheses, the curvy ones. Negative infinities always get curvy ones, and this is a filled in circle, and that is when you include the endpoints. So including the endpoints would look like that, and so we would put a bracket by the 2. I know some of you are getting the hang of this. If so, you can fast forward, but let's keep going through these other ones. For this problem, we'll treat each side as 2 separate intervals. So first, let's look at the left side. It goes forever and ever and ever in the negative direction. So it'd go from negative infinity all the way up to 2. And since it involves an infinity and an open circle, both of the parentheses are curvy like that. Then we'll say or, and we'll do the same thing, but for the right side of that. This time the low number's 2, and the highest that goes up to is positive infinity. We have a comma in between them, and they both get the curvy parentheses again. Last, we have the interval going from -1 to 1, so -1, comma 1, and both of those are open circles, so they both get curvy parentheses. The other interval goes from 3 to 4, so we have 3, comma 4, and those are both filled in circles, so they get these straight brackets. The last thing we'll do, just because I know you'll see it in future math classes, especially the further and further you go, it's called set builder notation. It's where you involve the set of numbers that you're talking about. Usually we're talking about real numbers, but you could narrow it down to integers or whole numbers or natural numbers. So what you do is, in case you think that that looks kind of complicated, just look at this part of it. You'll notice it is the exact same thing as the inequality. The only difference with set builder is we add these brackets on the end, and then this x with that straight bar right there. So when you say set builder notation, you just say all numbers such that, and then you say the inequality, x is greater than 2. So right here we would say all numbers such that x is less than or equal to 2. So that little bar right there, it basically means such that, if you want to jot that down. So when we read this one, we say the set of all x's such that x does not equal to, and x is an element of the real numbers, because we highlighted the real number line. The last one would say the set of all x's such that x is in between -1 and 1, or x is in between 3 and 4. So that's basically it for set builder. I would just make sure you know how to write the inequality and then put the brackets around everything with the x and that bar that means such that. So let's try some of these examples. Like I just said, we would say all x's such that, because we got to that bar, and then we would write down how we would say that out loud. X is, and that arrow is pointing to the right, so that means it's a greater than. X is greater than or equal to -3. I want you to try number 2 on your own, but I'm going to give you a little hint. If this was on a number line, it would look like this. -6 would have an open circle because it's the lowest number, and that is a curvy parenthesis. And then 4 would also have an open circle, and the shading would be in between them. So let's see if you can answer that one. Let's also see if you can draw a number line for number 3, and then answer number 4 and 5. Good luck.